Hi all, welcome to second part of the video lecture on notion of efficiency. So on the course algorithm analysis and design. So in the first part of the video lecture we saw the how we can compare different algorithm and it can come up with the most efficient algorithm. Okay, so what is the importance of efficiency as well as how we can do this comparison, how we can do it in a platform independent way. So what is the problem with the platform dependent analysis? Those things is were what we discussed previously. Now let's continue our discussion. So by taking some case studies. So let's take the first example like we already seen this finding maximum. Okay, so let's take that. So the algorithm, the basic algorithm that we are using most of the time. So first element of the array you can assume like the maximum element. Then what you can do is you can run a for loop from I is equal to 2 to some n number of iteration. In every iteration you will be checking if this a of I is greater than max. If that is the case, you can update this variable max with a of I. Okay, and let's see how we can do that step count analysis here. Okay, and this step count analysis is fundamentally what we are doing as a platform independent way of analyzing algorithms. Okay, step count analysis. And hope you remember what is happening is we will try to count the number of times or the frequency of the primitive operations. Okay, and let's see that how we are doing it and all the fundamental operations. Let's focus, and here you can see that at this here we are having a assignment statement, right? Assignment statement. On time it is being executed, and here you are having, if you are observing this for loop in a more detailed way, if you are simply looking at the number of instructions, so that is a more abstract way of analyzing the algorithm. You will see that this is being executed some 2 to n that many times, and maybe a false condition also like that. But if you are looking it in detail, you can see that here assignment is involved, right? So assignment in the sense every iteration some kind of I. So initially you will initialize I is equal to 2, then every time you will increment this I. So that increment is involved. So even though written like that, I is equal to 2, I less than or equal to n I plus plus. So that is how you are writing this loop, right? So you are incrementing I as well as you are assigning that, you are updating that I. So assignment, increment, everything will happen, and also this checking like whether this I is less than or equal to n or not, right? So that condition check. Okay, so that is where the comparison is happening. So all those things are involved here. Basically these three operations are involved here, but if you want you can view it as a single line, that also fine. Okay, so that is a more abstract way. So this is somewhat detailed. Now again here assignment is mainly comparison is mainly happening whether a of I is greater than max or not. The comparison operation you can see as the only one, right? So here it is assignment. I am assigning max with the a of I. So that about it. Now let's count how many times these things are being executed. Okay, so what you can see is, so the very first line, this is just executed on time only. Now if you are looking at this one, this is being executed from I is equal to 2 to n, right? So how many times it is being executed? n minus 2 plus 1, because I is equal to 2 onwards. Okay, so this many times this will be executed and the condition will be true, and it will execute one more time, means it has to come out from the loop, right? So the last time when it is checking, it will see that I less than or equal to n, that condition violated. So that checking also involved, right? So one time it will execute for a false condition. Okay, and the last time there is only comparison involved. In other two case, this the true cases n minus 2 plus 1, that many times this assignment, increment, comparison, everyone is there, but in last time there is no assignment or increment, but it executes only this comparison. Okay, so if you are focusing more precisely, if you are looking at it's like this many times number of lines. Okay, you don't want to be that much specific, you can approximate it to be some n number of times, fine. If this is being executed, so here we are talking about this particular line. Okay, n number of times, this this is inside this, right? So it will go inside the loop only when the condition is true. So the condition is getting true for n minus 1 times. Okay, so this inner line is getting executed n minus 1 times, and in each of the cases this max may or may not update. So let's assume the worst case scenario. So why I taken it as n minus 1? So in the worst case, I am assuming that in every iteration that max is getting changing. Okay, so we are going to come up with the upper bound of the running time, but in in reality it may not be updated every time, so that the actual running time will be less than this. So I can say that this is a maximum time taken. Okay, something like that. So that about it. Now you can just find out the total step count. Like this total step count will be, just add them all, right? The one time that first line being executed, and n times this the second line, that for loop get executed, and n minus 1 times that comparison statement, that is that if condition get executed, and another n minus 1 time that assignment get executed. Now to complete the algorithm, finally there may be some return statement also, say return max, and let's see, like it's getting executed, just a return, right? So either you, if you want, you can ignore it, or some kind of control transfer is happening, right? So that is getting executed just one time. Okay, so that also, if you want, you can count if you want to be more precise. And here also some minute difference is there, but still okay, something. So approximately, it's like some 3n. Yeah, this minus 1 minus 1. Okay, around 3n steps, or approximately 3n steps, like that I can tell you. So you can see that the step count of this particular max finding algorithm is found to be 3 times. So RSS. What is n? In all these cases, this n is the number of elements in the array, or the size of the array. Okay, so that is your n. So always we are trying to express running time as a function of the size of the input, that we already seen, right? So that about it. Okay. Now the same question I can ask you, right? So here you find like there are 3n steps involved, right? Now when it comes to a specific architecture, right, for a specific architecture, this one step could be, or some dominating operation you can focus on every step, like here assignment, comparison, increment, all are happening, but when I am counting like that, something which is most frequently occurring out of assignment and comparison and increment, you can focus, and you can say that one step or one basic operation is taking some x clock cycles. Okay, I don't know exactly, so that you can find out the actual system time, right? So the actual execution time with respect to a given architecture, you can say that it is something like 3 into n into x into some tau. Tau is the clock time. Okay, so like that. So this many units, like say seconds, and also what I am trying to say by this is like it's not much away from the actual platform dependent analysis. Still it is close to the reality. So at any point you can convert it into the actual time, in system time, in say seconds and all, by simply finding the number of clock cycle for the dominant operation as well as the clock time. Okay, so now it is specific to the architecture, but when somebody is saying like this is a running time, okay, you can see that it is something platform independent. So that is the benefit of this kind of a step count analysis we are having. Okay, let's take so this is the first example or first case study we are considering. Let's see one more case study so that this concept will be very much clear to you. And now let's take say the Fibonacci series example, right? Series example we can take, and let's see the algorithm and try to analyze. Anything you can take. I'm randomly picking few, like the algorithm. So first you will initialize some variable. Let the first Fibonacci number be 0, second be 1, so that this will be, or initial value you can give anything. I'm randomly giving values, that's all. 5, 8, then 13, like that it's going. Now so that I am initializing like a equal to 0, b is equal to 1, be the first two numbers, so that I am trying to find out the nth one. Or if you want, you can print them. Okay, so whatever things you want, you can do that. For I is equal to 2 to some n, what I am doing is some variable c I am taking. C is equal to a plus b, and in every iteration I just want to see what is my c. And finally the c is going to contain the nth Fibonacci number. If you want, you can print all Fibonacci numbers, or you can simply return the nth one. Okay, so according to the need. Okay, now you can update your a variable a with the b and b with the c, so that next time you can add these two things. So this is something like this. You can write the code. If this is the pseudo code or sequence of steps, it's not a complete program anyway. Many things are missing. If you want, you can add them also. With respect to this pseudo code, I am trying to have an analysis for this. So here you can see that this is a I mean, this is some kind of assignment operation, and that is getting executed one time. Here it's again assignment operation getting executed one time. Here this is getting so I'm not going in detail, like this is having increment, assignment, comparison, etc. So in a much peripheral way I'm trying to analyze. So this loop is getting iterated for n minus 2 plus 1 time. So this many times it will be true, and this is the condition, and that's false case. Okay, so this is approximately some n time, so that all these inner lines get executed some n minus 1, n minus 1, n minus 1, n minus 1 times. Okay, so that you can try to find out the total running time. It's like for some 5 n times minus 4 plus 2, so it is something like 5 n minus 2 steps. Okay, so if you want, you can add more things into it. If you want, you can have a print statement that print this a and b, so that one more step will be there, like that. Okay, so I think I can modify at this point. Okay, it's up to you, because I try to print the c here, so that I'm printing this a, so that is on printing, and another print statement where I'm printing this b. So that what I can see is this statement is executed it's taking some on time, this also taking some on time. So these are all some assumptions I am taking. If you're saying like a print is a some, I mean, inbuilt function, it's having a number of steps, don't worry at this point like that. So this is something that's taking constant time. So in actual analysis we will focus on the so this kind of inbuilt functions and all you can ignore, because it is everywhere, right? So default you will be asking them. So the other types of basic operations you have to focus, and that defines the actual logic of the algorithm. Okay, this printing and all you ignore, command line, those things. Okay, anyway, this is first of all, it's not going to give you the exact count. Okay, so here you are getting like some 5n minus 4 plus 4, so it's around some 5n steps. Okay, now again you can go do it in a different way, where I'm a little bit more detailed. Like, so what I'm trying to say is, this is say one time fine, this is also one time fine, and all those again one time, and sorry, this particular line, so this also for one time. Now if you are looking at this for loop, you can see that it is getting executed that n time only, yeah, n time, but inside this for loop you can see that assignment, increment, and comparison operation, so that I can say that it is around some 3n number of operation, like that. Okay, similarly here also, if you want, you can say like there is addition as well as that assignment is involved, so it is something like n minus 1 but 2 times. Okay, so this is again n minus 1 times is executed, and this is also n minus 1 times executed, and this also n minus 1 times executed. And finally if you add them all, but you will get some n 3n, 5n, and 8n. Okay, 8n. So here minus 1 minus 1 minus 5, and so it's around some 8n minus 1 steps. Okay, fine. Anyway, whatever it is, so next we will see something called some asymptotic analysis. From step 1 we move on to asymptotic analysis, where this constant everything we will ignore, and finally we will write it like order of n. So both are actually order of n. So that notation I didn't define it, that's why I'm not giving that feel about you. So these constant everything are finally not much significant. That reason everything I will let you know that time. Anyway, now my intention is to make you clear about the step count analysis. You can do this way or this way or something specific to the textbook and all. We may take on example that is explained in the textbook, that also we will see. Anyway, this is the way. Okay, so you can define clearly what you want and accordingly you can do the analysis. So some minute things. So what you can see that this is more close to the reality, right? So in reality, suppose I have an architecture, say some architecture I am assuming, some AMD architecture I am assuming, and I know that the cost of the increment operation is say some 1 microsecond randomly I am taking, and similarly the cost of this comparison operation is some 2 microsecond, and the cost of the assignment let it be some 3 microseconds. So that so let me take this as method 1 and this as method 2. So if you are looking at this method 1, it's giving the time given by this method 1 is very very close to reality, I can say like that, very close to reality, because close to reality in the sense here I counted everything in a very very minute manner, and I taken the time also in a maximum exact way. So that about it. But if you are looking at this method number 2, it is more abstract, right? More abstract and more away from the platform, right? So it's a platform, both are platform independent analysis only, but 2 is found to be more abstract analysis. Okay, fine, but we can make it more abstract, right? So more than this what happened in 2, we can do little bit more. That is what we will see in the asymptotic analysis. So the basic flow is like first we will do step count, then we will asymptotically means round of that figure to something order of n and all. So that we will see when we discuss that asymptotic analysis. That time I will let you know correctly with the mathematical meaning. So for the time being, I just want to tell you this. So this whether it is more abstract or and all, both are platform independent analysis only. Actually we will focus more on this, and we will try to be more and more abstract, so that it is there is no bias and all. Okay, so and it is easy for us, like if and it is handy for us. You don't have to think about worry about the constants and all. So this is the core. This is how we are doing. So I think these two examples are clear to you at this point. Similarly, you take any code and try to do this step count analysis, so that it will be a practice for your exam also. They can ask you anything. So what I was trying to say, you can do in your own way. Okay, but a formal example also we will see in the next video lecture, where how this maybe one example that is explained in the textbook, how they done. Okay, you can use that procedure also. Okay, that is somewhat more detailed. Yeah, that about it. Thanks for watching.